Hello again, this is Mr. Kusaj, and we are doing part 2 of lesson 4.2. Let me cover, so you don't get scared, let me cover the rest here. Okay, so we want to still work with angle measures, right? Degrees and radians. We still want to work with angles, but now we want to apply them, right? We want to apply them, meaning we want to solve problems with them. First, let's talk about arc length, right? Arc length, now the letters don't match. It's not going to be the first letter of what we're talking about. Arc length in my picture is S, right? And that's what the book uses. So there's a way of finding out how long this is, right? But you have to know the radians and you have to know the angle measurements, right? So if I give you how long, I'm sorry, did I say radius? You have to know how long the radius is and what the measurement of the angle is. If I give you those two numbers, you can find S, which is the arc length. There's the formula, right? It's that simple. If somebody asks for the arc length, S, you simply multiply the radius times the angle measure. Unfortunately, well, I shouldn't say unfortunately, we decided that with this formula, we're going to stick with radians. So your angle measure has to be in radians when you put in this formula. So if this angle is 30 degrees, you can't put 30 there. First, you switch it to radians, which is pi over 6, and then you put it in there, right? So it's understood that this has to be in radians. R can be in inches or whatever you want, or whatever it is, inches or meters or centimeters or whatever, okay? So let's do an example. Find the arc length. So let's see what arc length they're talking about. Oh, look. Here's the arc, question mark. My radius is 5, and my angle is pi over 4. Right? So how long is this in centimeters? Well, it's definitely going to be, I think, more than 5, I think. Let's see. Is it 5? Is it 3? Is it 4? How long is this arc length? Well, I have a formula. Put the radius here and the angle measurement here. And the angle measurement, by the way, is already in radians, so I don't need to switch it. So I go for it, right? 5 times pi over 4. Use the calculator, right? 5 pi over 4 centimeters. Or, if you change it to a decimal, it comes out to 3.9 centimeters. Oh, it's way shorter than 5, huh? Well, this is almost 4. So this arc length is 3.9 centimeters long. I found the arc length using the formula. Okay, how about this one? What is the arc length here? Well, here's my radius, I need that, and here's my angle measure, I need that, but I need that to be in radians. So look what I do. I do put 60, right? Radius times the angle, but right next to the 60, I put pi over 180. Why do I do that? Because we must have radians. And as you saw in part 1, if you want to switch degrees to radians, you multiply by pi over 180. So this will make it radians. So now you have radius, the r, plus the angle in radians. So just hit the calculator. 2 times 60 times pi divided by 180. You get 120 over 180. Reduce. You can use the calculator if you want. Comes out to 2/3 pi inches, right? Since we're starting with inches, our answer is going to be in inches. Or you can change it to a decimal. Right? That's how you find the arc length. Okay. How about the area? Okay, another simple formula, very simple. The area, sector area, that means we're not looking for the length of the arc, we're looking for the area on the inside. A slice of pizza. How much area does it cover? How much pizza is there? That's different from how much wire do I need to go around from here to here. That would be length. So now we're doing area. It has its own formula. Okay, and find the sector area. So let's see. If I'm going to find the sector area, they better give me the radius and the angle. They do. Here's the radius, 3 centimeters. Here is the angle, 7/8 pi. Right? So I'm going to put those two numbers in the formula. Boom. Like that. Right? Radius, angle. So the radius is squared. So what do we have on top? We have 1 times 3 squared times 7 pi. And on the bottom, we have 2 times 8. Oh, I went step by step. So it comes out to 63 over 16. Right? Don't forget pi. Can that be reduced? I guess not. So the only thing you can do is change it to a decimal, but 63 over 16 can't be reduced. Okay? So the answer is 12.4 centimeters squared. You know that area is always in squares, right? Okay. So area has its own formula. So we had the S formula, the arc length, and now this is the area formula. By the way, remember, the angle has to be in radians when you put it in, right? Okay. Last thing, 2 more formulas, but the good news is they're both tiny formulas, really small formulas. Speed. Okay? Speed comes in 2 forms, right? When you're doing circular speed. So let me try and demonstrate. So suppose I have a circle and you run a circular track and you run from here to here. That's from here to here, right? You do that, you go down that path, right? So I can ask you for the speed in 2 different ways. I can ask you how many meters per hour did you go? Right? Because that has a length. How many meters per hour did you go? Or I can ask you, it also has degrees or radians, right? How many radians or degrees, right? How many degrees per hour? Right? You covered 90 degrees in, I don't know, how long did it take you? So I can ask you for speed 2 different ways. That's why there's 2 different formulas. The linear speed is what is the speed that we're talking about in inches or centimeters or meters or kilometers, right? But the angular speed is degrees or radians, whichever one they want. Here they want radians, right? Per time, per hour, per minute. So if you want the speed, V is for velocity. I don't know what W is for. If you want the linear speed, right, you take your S and divide it by T. Well, T is the time. What's S? Remember what S is? S is the arc length. They'll either give it to you or you have to get it yourself. But this S is the arc length that we talked about earlier. Angular speed is almost the same thing, except it's the degrees, the angle, or the radians divided by T. Okay, so remember we decided that our angle is always going to be in radians for the formulas. Okay? So basically, they're the same thing, except one is length divided by time, the other one is angle divided by time. Right? Oh, I say so here. T is time. What is S? S is r theta. That's the old formula. Okay? What is theta? That's just the angle. So they got to give you the angle in radians. Okay? So here's The only example, and we're done. Okay. All right. So a wheel turns 140 revolutions per minute. So in 1 minute, it turns complete circles. Revolution is a complete circle. 140 complete circles in a minute. Find the angular speed. So we go to this formula. So the angular speed is, now they got to give me the angle and the time. Right? Now 140 revolutions, that means 140 circles. What's the measurement of a circle? 2 pi. Right? In radians it's 2 pi. In degrees it's 360, but we got to use radians. 2 pi. So the wheel turns 140 times 2 pi in a minute. Right? So the angular speed is 280 pi in a minute. Where did 280 pi come from? Well, 140 turns. A turn is a circle, 2 pi, so 140 times 2 pi is 280 pi. Right? Per minute. Right? The time goes in the bottom. Right? Angle over t. What kind of angle is that? Well, remember, it's 140 circles. One circle is 2 pi, but we have 140 circle, right? 1, 2, 3, 4, 5, 6, 7, 140. So 140 times 2 pi is 280 pi. I'm done. Just write it nicely. The angular speed is 280 pi radians per minute. Or, if we change it to a decimal, right, just hit the calculator. 280 pi is 280 times 314. Just hit the calculator, times pi, you'll get this decimal, radians per minute. Wait, what happened to inches? No, we're not doing inches and centimeters. We're doing angular speed. They didn't ask for linear speed. Of course, if they did, and we'll do it in class, if they did ask for linear speed, right, we do this one. Okay, that's it. I'll save the try problem for class. But all we did in part 2 was, is it 3 formulas? Right? 4 formulas. So the S formula for the arc length, the A formula for the area, and then for speed, there were 2 of them. Are you looking for linear speed or angular speed? They had their own formulas. Okay, see you in class. Bye.